Okay. Now we move on to service level management, aligning IT with business requirements. I think I had mentioned it sometime earlier that uh, whenever you invest in IT, in technology, investing in technology doesn't give you a direct return on investment. So how do you justify the cost incurred in investments in IT? And most of the time the investment is very huge, and people are many times not aware of the amount of money and effort that goes into building and proper IT infrastructure. So when you do put such an effort and also invest so much of money, time, etc., uh, there should be a way you get back your returns, right? You cannot increase the cost of your product if you have invested in IT, because that doesn't justify, because market has got its own mechanism of driving prices of products. People will buy certain things for a certain amount. You cannot go beyond that. So just because you have invested so much of money and effort in technology and you want the returns on that, you cannot increase the cost of the product or service. So how do you get your return on investment? The only way is, when investing in technology, you must invest in such a way that it increases the efficiency of your organization, thereby reducing your operational cost, which will contribute to the return on investment on technology. That is the only way you can do it. Slight changes here and there might be possible as far as pricing is concerned, but not big. Looking at the total investment you have to put in, you may not be able to justify that. So the only way and the most what you call efficient way is increasing the efficiency of your workforce, the processes, in such a way that the cost of running your business comes down drastically. Now, if you look at banks, earlier banks used to find it very difficult because they have had so much of employees. The salaries were comparatively less because you had to maintain such a big task force. But later on, after computerization, you saw that salaries went up very high, right? Primarily because when technology took over, of course, the initial investment was there, but on the long run, your system became so efficient that you did not need that many people to monitor the business. So only the key areas the employees used to, banks used to have their own employees. All other things were basically outsourced to third party. So that is how so it's actually a very tricky affair, getting your return on investment on technology. So that is where we say aligning IT with business requirements. Now, if you want to do it efficiently, you need to have a perfect way of understanding your business, understanding technology, and then probably making sure that you use the right technology, the app technology, to run your business accordingly. That is the only way possible. That is the only way you can make sure that you are using technology to the benefit of your organization. So that is what we mean when we say aligning IT with business requirements. What are your business requirements? And IT should be aligned with the business requirement, because technology is available. Doesn't mean you have to get technology, and doesn't mean that all these good technologies are going to be useful to you also. You need to use technology only if needed and to the extent it is needed. That's all. Just because technology is there doesn't mean you have to get it. Now, say a small, simple example I can give is telephone, mobile phone. Right today, we have only smartphones available in the market. Now, just because you need a phone, will you buy an Apple iPhone? You won't do that unless you have sufficient money to buy it, right? It would not be sensible enough to take a loan for that and then buy it. Because this device, by the time you complete your loan, this device might get outdated also. I'm talking generally, not only on iPhone, generally on technology. Agreed that it is the best product available in the market. But the first question is, can you do it? Can you afford it? And is it economically feasible for you? These kind of thought processes have to be there in people's mind while investing in technology. And many times what happens is you don't get a 5-year plan or a 6-year plan in technology. Your current technology might get outdated in a matter of 2 years. So after 2 years, you may be forced to upgrade systems. So that also has to be taken into consideration. So your return on investment also should come in a short period, because after that, you're going to again invest money in technology. Now, how do you align the purpose, objectives, and scope of service level management? Then capturing service level requirements, understanding the service level agreement, monitoring and improving service delivery, interfacing with other service management processes. This is how you basically align your requirements to the business requirements. The purpose, objectives, and scope of service level management should be very clear for you. Capturing service level requirements, you should be able to do it in very detail. Understanding the service level agreement, what kind of commitments are you getting or what kind of commitments are you giving? That should be very clear. Then monitoring and improving service delivery always. Then interfacing with other service management processes. So these kind of things have to. Now, SLA management, the best practices. Availability management, right sizing the business needs. Capacity management, setting up the process. Strategic information security, the holistic approach. Business continuity management, BIA. Service catalog management, supplier management. These are the things which we have to go through as we proceed. We'll see. Service level agreement. We have mentioned about this in the previous sessions. Service level, service as SLA, service level agreement. Now, this is nothing but an agreement coming between the service provider and the service consumer as to what kind and what level of service will be provided for that particular person from the service provider's point of view. So SLA is the short form for service level agreement and refers to a documented negotiated agreement between a representative from an IT department and a representative from the end user side. So this is the IT person from the IT department is the service provider, and the person who is consuming this service is called the end user department concerning the quality of service that is delivered. What do you mean by quality of service? Say, for example, internet downtime. Many companies have a policy like within 2 maximum, depending on the type of what do you call issue or problem, half an hour or 1 hour, 30 minutes or 24/7. Say they tell you in the beginning itself, and they charge you differently also for these different types of service. Say best quality service might be 24/7, 365 days a year. So you have to pay much higher for that type of service. Now, if you want only 24/7, 65 days a week, you have another option for that. So your service will be provided only during that time frame, Monday to Friday or something like that. Another option you have is once in a week or a weekly schedule that you can have, right? Or you need something very critical like 1 hour service. The call should be addressed in an hour time. You have to pay accordingly, right? So today there are different levels of agreements given to people, I mean, end users by service providers also, and they charge them accordingly. That depends. Now, which to choose depends on you and the criticality of your business. Common SLA metrics include percent uptime, that is called availability, average response time, and escalation procedures for problems. The one is percentage uptime availability. How much time the system is running. Now, that is most important. If you look at a banking application today, they want it running throughout. So 99.99% uptime is demanded. 100% we don't say because it is practically not possible. But majority of the time, I can say that 95% of the time it should run at 100%. I cannot compromise on that. So percentage uptime availability, average response time. If there is a complaint, how fast does the service provider respond to your complaint? Now you take an average because sometimes due to various reasons, like if there is a block, there might be a delay, right? So that is why they say average response time. If you are maintaining the same average response time, if it is high, good. Sorry, if it is high, it is bad. If it is low, it is good. Lesser the average response time, the better the service that is provided by the person. And finally, escalating procedures for problem. Now, if you are not getting response at the first level, what do you do? That is the next question. You cannot, you don't know what to do. So they give you escalation matrix also. They tell you whom to call after this, whom to report to after this, or automatically if they have escalation procedures, after this level, if the response is not done, it goes automatically to the next level. So that is called escalation because you should not be stuck by the first. Earlier, what used to happen was once a service engineer is allocated to you, you were dependent on him. He was the person who keeps on attending your calls. But nowadays things have changed a little. You have multiple people. They tell you whom to contact also. Earlier, nobody told you if this person doesn't perform, whom do you connect with? But today it is very clear. They mentioned the person's name and his phone number and his office address and the land phone in his office also. So that at any point, an email address, definitely yes. So if you don't get a response at the lower level, or you're not happy with what is happening at the lower level, you can always escalate the problem to the next level without asking anybody. So they can make an inquiry and help you out at the earliest. Now, this is something which you saw earlier. This is regarding an IP, ISP. So here, one Internet Incorporated gives you 99.94% uptime. That is what they promise you. Now, there are so many. I'm not going that into detail. So as you go down, you can see GoDaddy software is 99.44. So this is, as per this list, the lowest, takes the longest response time. Key process service design, ITIL version 3, service level management. Now, service level management is capturing service level requirements, SLR. SLR documents requirements in the language of business. SLRs are expressed as business standards, business understands, requires domain knowledge, contain definition of services and their key performance, availability and targets. SLRs are translated to SLAs by the IT service provider to make those services available with the help of external or internal suppliers. So service level requirements are expressed as business understands, requires domain knowledge, right? It is more not technical details of your infrastructure. It is more the domains. Whom are you developing this for? And what is this domain area? Right? Say, for example, refineries is a domain area. So you have people specialized in that. HR is a domain area. So whenever you build an infrastructure, the first thing that you have to understand is what is the infrastructure, what is the domain area you are going to address. Only then you will be able to properly design a infrastructure. So for that, you need domain knowledge also. Today also we say software developers, you know coding, but if you don't have any domain knowledge, then it will be very difficult for you to survive. People specialize in hospitality industry, people specialize in healthcare industry, people specialize in IoT devices, which is a domain area again, right? People specialize in what you call spreadsheets. People specialize in operating system. These are all domain areas. The language used is not that important there. Right? Most of the students, what happens is they think the language is the most important. The language keeps changing, platforms keep changing. You people who are already working might be exposed to this. You know, you understand what is the importance of language. Language is the least important thing. The project domain area is the most important. Many times you get projects based on your domain experience, whether you've handled these kind of projects earlier or not. It is not based on your language. Language you are supposed to pick up or you are provided training, right? Now, contains definition of services and their key performance availability targets. So how critical each service is. Then SLRs are translated into service level agreements by the IT service provider to make those services available with the help of external or internal suppliers. So if you are developing an SLA from an SLR, it will also be clearly mentioned about, they also clearly mention about services available with the help of internal and external suppliers. Now, SLR document. Typical example of an SLR document, it specifies the name of service, clearance information with location and date, service level manager, client, service description, short description of service, users of the IT service on the client side, breakdown of the offered service into service groups, example along infrastructure components or IT applications for each group, which services are offered, what are the services they offer, handling of service interruptions by telephone or remote access on-site, user services, user administration, installation, what actually is required of the offered services, etc. Service times, availability requirement, number of interruptions allowed, availability threshold, downtimes for maintenance, number of allowed downtimes, pre-notification periods, procedure for announcing interruptions to service, planned, unplanned, etc. Then performance requirements, required capacity, lower/upper limit for the service, allowed workload/usage of service, response time from applications, reaction and resolution times according to priorities, definition of priorities, etc. for the classification of incidents, requirements for the maintenance of the service of in the case of event or a disaster. So most of the aspects are covered under this. See, service description, short description of a service. What are you supposed to do? Users of the IT service on the client side, right? Breakdown of the offered services into service groups, example along infrastructure components or IT applications, that for each service group, which services are offered, example, handling of service interruptions by telephone, by remote access on site, user services, user administration, installation, etc. What quality is required of the offered services, example, service time, then availability requirement, number of interruptions allowed, availability thresholds, downtime for maintenance, everything, each and everything you can think out about a infrastructure implementation. Performance requirements. What is the criticality of the application and what is your expected performance there? Required capacity, lower and upper limit for the service, allowed workload usage of the service, response time from applications, reaction and resolution time according to priorities, definition of priorities, example for the classification of incidents, then requirements for the maintenance of the service in the event of disaster. SLA or SLM, SLA creation. How do you, what do you say, create a service level agreement, right? Second, okay, so SLM, that is SLA creation. Best practices for SLA creation. Separate SLAs should be created for each IT service that needs measurement. Avoid bunching of multiple SLAs into a single SLA for the entire catalog. Example, all desktop users related requests such as ID creation, termination, email requests, etc., as they may be differing constraints and timelines for fulfillment. An SLA must be quantitative, well researched, and authoritative. Then design of SLA must be based on quantitative data, based on research and practical considerations. SLA must be measurable, SMART, specific, measurable, achievable, uh, relevant, and timely. SLAs require periodic review and adjustment as a part of ITIL continuing service. Improve core area. For any changed service, it must be ensured that its SLA gets updated to reflect the new reality. All these things I think we have already discussed, so I don't want to explain it again. SLAs should account for usual and unusual exceptions. Example, new computers will be configured and delivered within 5 business days, except for weeks where a holiday occurs. In the event of natural disasters like flood, tsunami, or earthquake, SLAs can be relaxed. Now, customer-based SLAs, uh, service-based SLAs, and multi-level SLAs. Now, individual predefined services can be shared by number of customers, or individual customer may use a set of service specifically tailored to his business. Customer related SLA, agreement with specific customer or customer group covering all the IT services they use. Example, a single SLA covering payroll, administration, HR, purchasing, financial management, etc. for a small business, right? Service-based SLAs, agreement with all the customers of a specific service. Example, intranet or email service, which is a common service across many organizations. Customers may demand choice differentiation, problem in identifying user group as the representing the customer, multi-level SLA, elements of services common to all customers are covered by corporate service level SLA. Specific issues pertaining to select customers are covered under customer-based SLA. The corporate SLAs, example, corporate email service, internet, etc. Customer-based SLA covering common service features, hours of operation, availability, security, reliability, support services, etc. For general financial system, payroll, council tax, etc. Then under that comes service specific SLA, payslip production and printing. Then another example is council tax bill production. Now, service level agreement of maintenance, application support. Severity 1. We have seen the same table in a different way earlier. Complete loss of service. Basic plan is 1 business day. Standard urgent is 2 business hours. Premium is 2 hours. Now, 2 business hours basically means when you are working, right? 2 hours when you during your work time. Here, 2 hours means 2 hours irrespective of whether you are working or not. Right? Say, for example, an ATM down in a critical junction, which will affect the bank's business so much. So, irrespective of whether it is day or night or whether it is office working hours or not, they need support for that. That is 2 hours. But when you say 2 hours, 2 business hours, it is normally during the working time of the bank. That is if the bank working time is 9 to 5, 2 hours within the. So if it is reported at around 4 o'clock, it can go to the next day also, right? Again, the same diagram which we saw earlier. Uh, Developing an SLA for uptime of application. Draw a visual representation of how the entire network is connected through which the application access is determined. Question at every entry point whether will this will this be a single point of failure? Decide on the redundancy and resilience based on RTO and RPO as agreed with the management. Check whether there is a third party service provider dependency and create a back-to-back agreement. Now, availability management. Now, availability definition. Availability is the process of optimizing the readiness of production systems by accurately measuring, analyzing, and reducing outages to those production systems. So, simple meaning, though the definition is looking complex, simple thing is how long the system works. That is called availability. When you need it, is it available to you? That is why the term availability is used for this purpose. Right now, the production system could be an email service, SAP service, CRM service, backup service, etc. For a customer, if the service is not usable, it is not available or down availability. For a supplier, it is a problem with the components resulting in outage, positive uptime. So from a customer's point of view, if the service is not usable, it is not available, right? Which you call the system is down. That is called availability factor. For a supplier, it is a problem with components resulting in outage. So causative, what is the reason and how fast they can make it up back? That is called uptime. Uptime is a measure of the time that individual components within a production system are functionally operating. This contrasts to availability, which focuses on production system as a whole. Availability is a customer centric, while uptime is supplier centric. So uptime is a measure of the time that individual components within a production system are functionally operating. This contrasts to availability, which focuses on the production system as a whole. Availability is customer centric, while uptime is supplier centric. End users mainly want assurances that the application system they need to do their job is available to them when and where they need it. Infrastructure specialists primarily want assurances that the components of the system for which they are responsible are meeting or exceeding their uptime expectations. Top 10 influencers of system availability. 1. Data center facility. 2. Server hardware. 3. Server system software. 4. Application software. 5. Disk hardware. 6. Database software, network hardware, network. So everything comes under that, right? Top 10 influencers of system availability. Anything, any issue with any of these 10 things will result in downtime. Now, what causes non-availability? One case is single point of failure. Say, for example, here you can see the router. Router is the device which connects the network completely. Now, if the router is down, the whole system will come down. That is why it is called single point of failure. You don't have multiple locations to fail. Just this device can bring your system down completely. So a single point of failure is a part of a system that fails. If it fails, will stop the entire system from working. Now, two common dilemmas in managing availability. One is the cost of outages against the cost of redundancy. In the scenario would be, I'll explain that with this example. Now, how do you take care of that? Now, here what you can do is have an additional router in place so that even if this goes down, the other one is there. But there you are causing redundancy of hardware. Now, again, should you go for that is a question because that depends on how critical your business is and how important your customer transactions are. If it is very important, you cannot miss out on anything, then definitely yes, your router should be duplicated, can be duplicated. If it is not so critical, you can probably have some time to get the router up back, either carry it there and replace it with another router, right? Something like that, like an ATM machine. You walk into an ATM. In critical locations, you will find that each ATM enclosure has got multiple ATM machines. Primarily because there should not be a situation where there is no ATM working for that particular bank in that location, because they know that this is an area where there are huge number of transactions. But if you go slightly inside, you will find that ATMs are not working for the last 2 days because bank also will take their own time to rectify it because they know that the ATM there is not that critical. It is once in a while somebody comes and withdraws money or uses that particular ATM. But of course, depending on the importance of the location, they might have installed an ATM, but the strategy they have for maintaining that particular ATM might be slightly different from the one they have for maintaining the ATM in the heart of the city. So cost of outages against the cost of total redundancy. That is something which you have to find out. If a system goes down, what cost does this incur as a loss to you? Right? Then how much will you have to spend in order to have total redundancy of a particular product? Like I told you, having another additional router. Routers are also expensive. So having or maintaining an additional router is very, very important. So the scenario would be network uptime is at an all-time high while an end user critical application is not available. Cost of building complete redundant network system versus loss incurred due to the application not available. So cost of building complete redundant network system versus loss incurred due to the application not available. So which is greater? Based on that, you decide. If your redundancy cost is higher, then probably don't go for redundancy. But if your loss incurred due to downtime, because if you don't have redundancy, there is a chance of longer downtime. So if that downtime is more critical to you, it can create huge loss for the organization, then things change. It has to go the other way. Multiple components usually correspond to multiple technical owners. This is the formula for disaster as far as availability is concerned. Several people in charge means no one is in charge. So distinguish availability from uptime. Now, multiple components usually correspond to multiple technical owners. This is the formula for disaster as far as availability is concerned. Several people in charge means no one, you have to put specific people in charge, right? Otherwise, everybody will move away from their responsibility. So distinguish availability from uptime. Working but not available. That is a different scenario. Available, it is ready for use, right? So you must clearly be able to identify what is more important to you. If it is availability, it is more critical. If it is uptime, yes, you have some time to get back. Now, primary difference between availability and high availability is that the latter is designed to tolerate virtually no downtime. All online computer systems are intended to maximize availability or to minimize downtime as much as possible. High availability refers to the design of a production environment such that all single point of failures are removed through redundancy to eliminate production outages. This type of environment is often referred to as being fault tolerant. So high availability refers to the design of a production environment such that all single point of failures are removed through redundancy to eliminate production outages. So wherever you feel that there is going to be a single point of failure, duplicate that device. If it is a server is typically a single point of failure. So you do server mirroring. You have two servers running the same application at the same time. If it is a disk is where the data is stored. So to make it more reliable, you make disk mirroring. You have two disks which are very similar, carrying out the same number of transactions. Now, this type of environment is often referred to as being fault tolerant. Now, slow responses versus downtime. Slow response refers to unacceptably long period of time for an outline transaction to complete processing and return results to the user. Slow response is mostly affiliated to performance and tuning related activities. Downtime refers to the total inoperability of a hardware device, a software routine, or some other critical component of a result that results in outage of production application. So downtime refers to the total inoperability of a hardware device, a software routine, or some other critical component of a system that results in outage of production application. Now, fault tolerant. Fault tolerant refers to a production environment in which all hardware and software components are duplicated such that they can automatically fail over to their backup component in the event of a fault. Say you've got a primary section and a secondary section, which are actually mirrored. You have a network management software, 50 fault tolerant logging soft network. So whenever something is down, it takes charge. The fault tolerant network take charge and then assign another device for that so that your system doesn't go down completely. Measures and methods of measuring availability, uptime, downtime, MTBF and MTTR. MTBF stands for mean time between failure and MTTR stands for mean time to repair. Percentage availability uptime is equal to hours agreed uptime minus hours downtime divided by hours agreed uptime. Scenario 1. A high critical application requires to be available between Monday and Friday 6 a.m. to 12 p.m. midnight and on Saturday from 7 a.m. to 5 p.m. The range of uptime calculation for 90 lower and 95 upper may be as follows. Monday to Friday 6 a.m. to midnight. So 5 into 18 is equal to 19 hours. Saturday 7 to 5, which is 10 hours. So 90 plus 10, 100 hours uptime is what you require. Lower availability is 90 hours, 90%, and higher availability is 95 hours. That is, lower availability is 90% of 100 is equal to 90 hours, 10 hours per week downtime. Upper availability is 95% into 100 is equal to 95 hours, 5 hours per week downtime. Now, network specialist gradually started targeting 99.9% uptime per week, which makes an allowance of only 10 minutes downtime per week. Rule of nines availability percentage. Percentage availability 90, weekly hour downtime 10, weekly minute downtime 600, daily packages not delivered out of 10K 1000, daily packages not delivered out of 1 million 99% availability, weekly hour downtime, weekly minute downtime, daily package not delivered out of 10K 100, daily packages not delivered out of 1 million 10, and so on. Okay, strategy of deciding availability, the 7R technique. One is redundancy, elimination of single point failures, like I told you earlier, eliminating single point failure by having redundant systems. So power supplies, multiple processors, redundant disks, etc. Now, in larger organizations, you can see UPS will be there. After that, generator will be there. So even if UPS hangs around for 2 to 3 hours, after that, what? You have to have generator, all right? Now that depends on the criticality of your application. If you can afford downtime, then no, normally people go only for a UPS, they don't go for a generator. The moment the power goes off, they try to complete the job as fast as possible so that in case the UPS period is over, the system still works. Then reputation. Reputation of key suppliers of IT hardware and software. That again decides availability. Percentage of market share, industry report, customer references, track record of reliability, and repairability. Then comes reliability. Consistency of supplier services and products. Hardware and software perform empirical component reliability analysis using review problem management log, supplier logs, feedback from operation, customer experience, MTBF is equal to sampling, interval slash percentage of failures during sampling interval, etc. Then repairability. Ease of service technicians solving the problem. Average MTTR, which is mean time to repair, sum of repair times, percentage of failures. 5. Recoverability. To overcome monetary failure without any impact on end user availability. Availability to switch over to standby systems, recoverability is a design factor. TCP/IP packet forwarding is a classic example. Right, so recoverability is to overcome momentary failure without any impact on end user availability. So if something goes wrong, how fast you have an alternative solution to. Say one is ability to switch over to standby systems. Now, another example I can give you, if see generators are normally when the power goes down, somebody runs to the generator room and starts the generator. It takes time. It takes at least 5 minutes, right? Depending on where your generator room is, or it might take even 10-15 minutes. Now, can you afford this in a 5-star hotel? You cannot. So what do? They have an automatic trigger generator. It works like a UPS. The moment the power, it senses the power failure, immediately the generator starts. So the more efficient the generator is, the more expensive it is. That is also there. So the moment the power goes off, the generator starts working. Nobody has to go there manually and start the generator. So there is no power cutoff itself. If at all there is a cutoff, you might see a small blink of lights. That's all. Otherwise, everything works perfectly. So this is something, this is an example of recoverability. How far you are recovering from the damage caused by electrical failure. Responsiveness. Sense refers to sense of urgency. Ability to respond to automated recovery. Supplier response for an issue escalated. Having well-trained suppliers in-house itself. Many organizations do have people inside the organization. Say, for example, IT, if you look at it. Though there are guarantees, warranties, third-party maintenance, most companies have got their own internal IT team so that you don't have to wait for somebody to come up. Right? So that is for better responsiveness to issues. If something goes wrong, how fast somebody responds to it. Then robustness. Ability to stand up and deliver services continuously, even in case of natural calamities and other disturbances. This is based on business continuity planning. Now, when I talk about robustness, I can say server, for example. You can keep an ordinary machine as a server. Also, you get specialized servers available in the market. Now, what is the difference between these two? Primary difference is these are machines, of course, well, they'll work as a good server as long as you're not very critical about it. But can you think of hosting something like an Hotmail or Facebook account on that machine? No, absolutely not. That machine is not capable of taking that much of load. So there you need to go for a proper server itself. So you say server class machine, what you call, right? You need a perfect server in place. Next is capacity planning. Capacity planning definition. As its name implies, the systems management discipline of capacity planning involves the planning of various kinds of resource capacities for an infrastructure. Ensuring adequate capacity involves four key elements that are underscored in this definition. The type of resource capacity is required, such as servers, disk space, or bandwidth. The size of quantities of the resource in question. The exact timing of when the additional capacity is needed. Decisions about capacity that are based on sound, thorough forecasts of anticipated workload demands. So, as its name implies, the systems management discipline of capacity planning involves the planning of various kinds of resource capacities for an infrastructure. How much resource of what you require? Again, I told you earlier, IT infrastructure comes at a huge expense. Therefore, it is very important for us to spend money very carefully. So for that, you need exact idea about what you require as an organization. It is not about overspending or even limiting the budget also. You should not be stingy also. You should know exactly what you want and spend money most efficiently in procuring what you want. Just because you have money doesn't mean you can buy anything. No, because money also comes at a cost as an organization, right? No, ensuring adequate capacity involves four key elements that are underscored in this definition. The type of resource capacity is required, such as servers, disk space, or bandwidth. The size of quantities of the resource in question, the exact timing of when the additional capacity is needed, decisions about capacity that is based on sound, thorough forecast of anticipated workload demands. Reasons why capacity planning is seldom done well. One, analysts are too busy with day-to-day activities, both IT infra system analysts and program analysts. Two, users are not interested in predicting future workloads. Currently need is only state. Now, when you talk to the user, now why the question here is why capacity planning is not something which you can do it properly. One is you don't have people to respond to you, especially analysts are too busy with day-to-day activities. Second one is people are not interested. Ordinary user, maybe on one hand is not interested. On the other hand, he may not be capable of thinking about future requirements also. So what he does is whenever you ask him something, how much he needs, he will say only the current requirement. Now, users who are interested cannot forecast accurately, inadequate skills, experience, and no tools. Now, capacity planners may be reluctant to use effective measuring tools. Corporate or IT directions may change from year to year. Corporate mergers, acquisitions, and redirections. These might affect the overall IT strategy of the organization. Say, for example, a more traditionally looking management. When they hand over the business to or they sell it or some other high-tech company, a modern day company takes over the organization. The first thing they will probably do is implement technology there. They might be very tech savvy. They know exactly what they are doing, right? So what they will do first is replace the current system completely with tech system. So the whole idea about infrastructure itself will change. Planning is typically not part of infrastructure culture. Focus is on tactical operation. That means many times what happens with infrastructure is you may not be able to plan things properly. You must understand the situation at that point of time and then what do you call react accordingly, right? So it is more of a tactical decision rather than a pre-planned decision. Of course, initially you might be able to plan, but as the system starts functioning, it should be based on. Now, managers sometimes confuse capacity management, which is tactical, with capacity planning, which is strategic. So capacity management is managing the capacity, which is tactical. Look at the scenario and understand what is happening and take remedial measures accordingly. Whereas capacity planning is strategic, long term. How much your company is, what is a growth plan of your company? Based on that, what infrastructure enhancements you require, so on and so forth. The best way to combat this too busy and less focus on tactical is to assign a group within the I infrastructure to be responsible for capacity planning, explaining to end user how accurate workload forecasts assist in justifying additional computer capacity, and working with capacity planners to simplify user friendly future worksheet. So explaining to the end user how accurate workload forecasts assist. So people should understand what is the uh, purpose of capacity planning and what are the advantages of capacity planning. It should not be only the implementer's job, because without the end user's participation, you also will not be able to get a clear idea about what is the capacity planning you need to have, both tactical and strategy. Joint consultation with both developers and capacity planners who can show users how to do this can help elevate the drawback of inaccurate forecasts. Cross-training, documentation, consultation with the vendor. The turnover from prior users of the tool can help overcome the reluctance to use effective measuring tools. A dedicated planning group for infrastructure will be successful capacity planning. Capacity planning is strategic, a future-driven, while capacity management, performance, and optimization is tactical, a day-to-day activity. Now, that is something which you have to clearly understand. Capacity planning is strategic, long-term, whereas capacity management is managing your capacity. How effectively are you utilizing the resources that you have? Very simple. It is a day-to-day activity, right? Because every day is not the same in the organization. So depending on today's requirement, how are you going to manage the capacity part? Now, how to develop an effective capacity planning process? 9 steps here. 1, select an appropriate capacity planning process owner. 2, identify the key resources to be measured. 3, measure the utilizations of or performances of resources. 4, compare utilization to maximum capacities. 5, collect workload forecasts from developers and users. 6, transform workload forecast into IT resource requirements. 7, map and requirements onto existing utilization. 8, predict when the shop will be out of capacity. 9, update forecast and utilization. I think all the statements are self-explanatory. Then identifying key resources to be measured. What is it that you need to keep track of for effective capacity planning? You need to have an idea about the resources that are available. One is network bandwidth, because that is something which directly affects the performance of your system. Centralized disk space, centralized processors in servers, channels, tape drives, centralized memory in servers, centralized printers, desktop processors, desktop disk space, desktop memory, All these are factors that you must keep in mind while identifying the key resources. Measure the utilization or performance of the resources. These measurements provide two key pieces of information. One, A, utilization baseline from which future trends can be predicted and analyzed. Two, the quantity of excess capacity available for each component. For example, a critical server may be running at an average of 60% utilization during peak periods on a daily basis. These daily figures can be averaged and plotted on a weekly and monthly basis to enable trending analysis. Databases are often pre-located by database administrators to a size that they feel supports growth over a reasonable period of time. Hence, have a clear track on the growth of database. Usage of appropriate tools for monitoring and measurement is highly recommended, and each tool has its own merits and demerits. Now compare utilization to maximum capacity. The intent here is to determine how much excess capacity is available for selected components. The utilization or performance of each component measured should be compared to the maximum usable capacity. Note that maximum usable is almost always less than the maximum possible. The maximum usable server capacity, for example, is usually 80 to 90%. You can never use a server 100%. Similar limitations apply for network bandwidth and cache storage heat ratios, etc. So everywhere there is technically a limitation in what you can do with what is available. That is important. Now collect workload forecasts from developers and users. This is one of the most critical steps in the entire capacity planning process, and it is the one over which you have the least control. A typical workload forecast sheet. The number of total users, current load after 6 months, after 1 year, after 2 years. The number of users, concurrent users oriented. So you must have an idea about what is the current load and what is it going to be in the future, right? Only then you will be able to plan accordingly. Now, two things here. One is understanding the utilization of your capacity that can be received from the current load and how much growth do you expect in the organization. That can be taken as a 6 months milestone, 1 year milestone, and 12-year milestone. Now, after the workload forecasts are collected, the projected changes must be transformed into IT resource requirement. Sophisticated measurement tools or a senior analyst expertise can help in changing projected transaction loads, for example, into increased capacity of server processors. The worksheets also allow you to project the estimated timeframes during which workload increases will occur. For major application workloads, it is wise to utilize the performance centers that key suppliers of the servers, database software, and enterprise applications now offer. Now, update forecast and utilization. All these are purely theory based, something which you can very well read and understand. But I'm just reading through because at least you get an idea, because you may not get time to go through all the slides. So at least you remember something here and there. The process of capacity planning, and remember again, more than the exam point of view, it is on a career point of view. You need to understand these concepts very much. Right? You must have, so only then when you start working on, say, for example, tomorrow you are moving into IT infrastructure. The moment they say IT infrastructure, all these aspects have to come to your mind, though not in depth. You must at least remember that these are the areas which are covered under this particular. The process of capacity planning is not a one-shot event, but rather an ongoing activity. The maximum benefit is derived from continually updating the plan and keeping it current. The plan should be updated at least once a year. In a larger setup, updates on a quarterly basis is required. There is a linkage with production acceptance process where similar capacity planning formats are used to determine the resource requirement for new applications. Now, helpful hints for effective capacity planning. Start small. Begin with small scope and expand later. Don't start big, right? Because when you start big, you might land up always, most of the time, what will happen is you will procure more than what you actually require. And always remember, technology gets outdated fast. So what you are planning should be for a 2-year period, not more than that. Earlier, it could be a 10-year plan also because technology was not developing so fast. Now, 2 years now itself, I would say it is too long because 2 years, things can change drastically. Last 2 years, AI has revolutionized things. So we know, though AI has been there for the last 50 years, the concept has been there for 50 years. But today it is there in the common man's hand and people are using it right and left for everything they need. So the usage of AI has gone up drastically. So if you had planned for something with 2 years back technology for the next 5 years, you would be absolutely out of place by now. So we should be very careful while investing in technology. So that's why we say start small. Begin with small scope and expand later. Speak the language of your customers. Workload format data only from customer viewpoint. Consider future platforms. Consider only tools support current and future technology agnostic. Now share plans with your supplier. The cost of drivers, agents, installation, time and labor, copies of licenses, updated maintenance agreements are identified and agreed upon. Anticipate non-linear cost ratios. Situations where a modest increase in capacity end up costing an immodest amount. Plan for occasional workload reduction. A forecasted change in workload may not always cause an increase in the capacity required. Prepare for turnover of personnel. At least two must be familiar with the methodology. Strive to continually improve the process. Remains PDCA, plan, do, check, cycle. Evaluate the hidden cost of upgrades. So this is again a repeat slide. These points have come before also. So some aspects you must consider while going for upgrade, make your capacity plan. Now uncovering what are the hidden costs. Hardware maintenance, cost escalation clauses in service agreement. Right, we may not directly notice it, but always remember hardware maintenance cost is something which keeps escalating year after year because technology, the moment technology gets outdated, your products move out of warranty, maintenance cost increases. Technical support. Support comes only at a low cost, not free. Then software maintenance, license fee and 25% cost of the baseline of for year. Memory upgrades may lead to changing the processor, which is additional cost. Channel upgrades. Additional disk may lead to adding new channels. Cache upgrades. Additional disk required cache memory expansion. Data backup time. Additional disk increases backup time, may require faster channel. Operation support. Increasing backup window or adding more PC equipment require more operational support. Offsite storage. Additional expense for offsite storage due to more storage capacity. Network hardware, network support, floor space, power and air conditioning, etc. All these are, you can say in one way, indirect costs, or you can also say hidden costs, which we may not notice initially. Capacity management tool. There is something called the VM1, IntelliMagic Vision for SAN, Help Systems Performance Navigator, Elevate Capacity Management, True Site Capacity Optimization, Victana Platform, Lenovo Capacity Planner, etc. Now, strategic secure, another important area. The CIA trial, right? Confidentiality of the information, protecting data integrity and maximizing data availability. That is called the CIA triad. I4A's identity, authentication, authorization, auditing, accountability. Then OSI layer, open system interconnect layer. Now these 3 points are something which are very important. Now, primary goals is one is availability, integrity, and confidentiality. Security controls are evaluated on how well they address these three tenets, beliefs. Vulnerabilities and risks are assessed based on the threats they pose against CIA. Confidentiality, the measure used to ensure the protection of secrecy of the data, objects, or resources. Goal, to prevent or minimize unauthorized access to data, security measures, access control, data classification, encryption, steganography, network traffic padding, training. Attacks focused on confidentiality, capturing network traffic, stealing password files, social engineering, port scanning, shoulder surfing, sniffing, escalation, and of privileges. All these things you should already be familiar with, right? Now, object is a passive element such as a file, computer, and a network connection. Subject is an active element such as user, programs, and computers. Now, protecting data integrity. How do you do it? One is restrict access to data and objects. Activity logging. All activities are to be logged so that tomorrow, if you want to cross check something, you can always do it. Hash total verification. Object and data encryption. Rigorous authentication process. Right. In some cases, earlier it was only the user ID and password. Now you have user ID, password plus OTP, right? Then in case of banks, etc., you might have seen in some banks for carrying out each transaction, it is not enough to just what do you call? I'm talking about the bank employees carrying out transactions, right? If they want to record an entry, they have to put their finger itself. There is fingertip reader, finger scanner, right? Then intrusion detection system, trying to keep track of whether somebody is trying to get into your system. Then verification of object integrity across the storage. Then attacks on integrity, virus attacks, or the unauthorized attacks, malicious modification, system backdoors. Then comes logic bombs, error in encoding an application, and intentional replacement, Trojan horse. These are all attacks on integrity. Now, information availability. Availability, it refers to the ability of a system to grant data access to authorized objects timely and uninterrupted. It means that efficient, uninterrupted access to objects and prevention or denial of service. Technology controls for improving availability. Elimination of single point of failures, POF. Acceptable level of performance, SLAs for error or for correction and of interruption. Build redundancy, reliable backup and restore, prevent data loss/destruction, design effective intermediary delivery system, effectively use access control, monitoring performance and network traffic, defense in depth mechanism. Threat to availability, if you look at it, you have device failure, environmental issues, heat, flooding, power loss, etc. Then object destruction, then software errors, denial of service attacks, communication interruption. These are basically your threats to availability and technology controls for improving availability. This is another important slide. Okay, I think we can stop for the day. There is no quiz today, so I think you can leave.